Point number 3 is, if we have data and then you somehow run an algorithm, get a model out of it. Now what might happen is when you deploy it in the real world, right? So let's say you have some machine learning model which you want to use in the real world. Now it might so happen that this data is actually confidential. Maybe this is healthcare data, or maybe this is data which is, let's say I am going to train a machine learning model to predict your exam scores, right? So your 12th standard board exam scores, right? So and the data that I'm using is the marks that all of you have gotten, all of you and everybody in the country has gotten so far. And now you as an individual, may think that your data is very confidential. You don't want to tell anybody your marks. Now, but then you are okay to give it to a system, and that system is going to run an algorithm which will give a model which will make predictions as to whether somebody, if some features of a person is given, it will predict whether that what is the marks that that person will get in their 12th exam, board exam. Now let's say that model is being shared with an adversary. An adversary is somebody, an evil person, right? And now you gave the data to the model, to the algorithm, with the hope that your data will remain confidential. Now the data is not being given to the adversary or to the evil person. Only the model is being given. What is the model? The model is just going to say, given a new data point, it's going to tell me whether it is, whether you will pass the board exam or not pass the board exam. Let's say that's the model. Okay. So let's say decision tree is the model that we are outputting in this particular example. Now let's say an adversary has access to this decision tree, right? So we have extracted the important information from the data as in the form of a decision tree, but then let's say an adversary or an evil person gets hold of this decision tree. Now what if the adversary is able to figure out something about the data by just looking at this decision tree? For instance, if the adversary is able to figure out whether you as an individual passed your board exam or not, right? So if that information is a confidential information, and if the adversary is able to figure that out by just looking at the decision tree, then that is a breach of privacy because your data is confidential. As another example, think of a healthcare setup where somebody's data is there in the data set, and their features are there, and the label is whether they have a specific disease or not. Now again, I train a model to predict from features whether a disease is present or not. Now if the adversary gets hold of this model and is able to figure out if a person has a disease or not, then that's a big issue, right? So I don't want the adversary, by using the model, to figure out something about the data, right? The adversary has the model, but then if the adversary is evil and wants to figure out whether you have a particular disease or not, and if the adversary is able to do that, then that's breach of privacy. So we want models which are private, and a real example of this happened in 2007 when Netflix, which is the movie platform, they released a data set where it was a data set like a Excel sheet. Think of it like an Excel sheet, where you have users, user 1, user 2, and so on. User, let's say 10,000 users were there, who were watching movie 1, movie 2, and so on. Movie, let's say Netflix had 5,000 movies at that time. Now every user is not watching all the movies, right? So user might have watched movie 1 and might have given it 3 stars, might have watched movie 100 and might have given it 2 stars. User 10,000 might have watched some other movie and might have given it 5 stars. Now user 1 has not watched many movies, user 2 has not watched many movies, and so on, right? So now the challenge was to predict, how many stars would a user give for a movie using this data. Now, why will Netflix care about this? Because if Netflix knows that this person will rate this movie very highly if he or she watches this movie, then it is in good interest of Netflix to show that movie as a recommendation to that user, so that that user will watch that movie and spend more time on Netflix, which is what Netflix wants to do, right? So make you spend more time on its platform. So it needs to predict which movies you will like, and for that it needs to know what type of movies users similar to you have watched. Let's say you and your friend are very similar in terms of your movie preferences. You have not watched a movie, but your friend has watched a movie, and if your friend says, hey, I watched this movie, it's a brilliant movie, then you would also like to watch it because you know both of your preferences are the same. Similarly, if Netflix can figure this out from this data that there are so many users, some users are similar in terms of their features. So if a user watches a movie, then it is very likely that his or her friends or users who are similar in feature to that user will also watch that movie, right? So now the challenge that Netflix gave to public was, here is this data which has user 1 till user 10,000, let's say, and movie 1 to movie 5,000. Each user has watched a set of movies. Now can we predict the number of stars for users for movies that they have not watched? Now, this was called the Netflix challenge, and it was a famous challenge for a long time. Now, Netflix realized that, you know, the fact that a person watched a movie or not might be confidential, right? So I don't want the world to know whether I watched a particular movie or not, for whatever reasons. Now, if you treat this as confidential information, so Netflix obviously removed the name and other location, etc., details from the data that it released. Basically, what it did was something called as anonymization, which amounts to saying that I will anonymize the details about the user, the personal details of the user, right? So which is his or her name, location, you know, and other identifying information, let's say, right? So about this person. Now, um, what happened was, by looking at the set of movies a user watched, and by using other databases, let's say like the IMDb databases. IMDb is the Internet Movie Database. There were some researchers who are able to figure out who these users were. That is, even though the names were removed from, let's say I just said it as user 1, releasing the data and just removing the names does nothing for privacy. That's the conclusion that people drew, because I just said user 1, I'm not telling you who this user is, but if you can identify that person in the other database. I mean, there are other places where that user has gone and given public information, let's say in databases like IMDb, etc., and now you can use those databases and then try to map it to this Netflix database and then figure out, reverse engineer who these users were. So essentially, I'm using some side information. In this case, it happens to be IMDb, which is the Internet Movie Database. But in general, what I'm not guaranteed as privacy is if I just remove the names and other some information about a user and release the data, it's not necessarily the private, because there might be other places, other data sets from which I can get this information and then try to match this information to the information given by Netflix and then figure out. Something. So we need more sophisticated methods to make sure that the AI ML data or the models that we release are private, right? So the third requirement of responsible AI systems must be, so far we have identified three. One is, if you remember, fair, two is explainable, and three is private. So these are three fundamental properties that an AI machine learning system should have to call it responsible, right? So it is our responsibility as algorithm designers to make sure that when we are deploying our algorithms in the real world, it is fair, that it is not biased towards anybody based on their age, gender, race, religion, caste, etc. It is our responsibility to make sure that even though the algorithms are very, very complicated, there is a way to, in a simple way, explain why the machine or the algorithm makes a certain decision, and it is our responsibility to make sure that if the data is confidential, then an adversary or an evil person will not be able to figure out anything about our data by looking at the model or the anonymized version of data that we release. So these are three aspects of responsible AI. There are other aspects also, but these are the three main aspects of developing algorithms which are responsible. Now there is being cutting edge research that is being conducted today as we speak, which are where people are, researchers around the world are developing AI ML algorithms that are fair, that are responsible, that are explainable, and also private. In this course, we are not going to talk about these algorithms, but as you can imagine, these would be fascinating, interesting ways to make the algorithms that we already know responsible, right? So feel free to think about how you would make these algorithms responsible. For example, how can you make a decision tree fair, right? So it makes sure, how can you make sure that a decision tree does not produce outcomes which are biased towards one race than other? How can we make sure that happens? What can you change, right? So in the training procedure of the decision tree, how would you change these things? These are questions for us to think about. Now again, in this course we are not going to look at the algorithmic aspects of this problem, but what I wanted to at least introduce to all of you is that today's AI ML algorithm, as you can imagine, these algorithms are being used extensively, right? So and they'll become more and more prevalent in our day-to-day use, right? So we will start using AI ML in so many day-to-day applications that we have to be very careful that this technology is not doing harm and hurting people as opposed to doing good for which it is actually intended, right? And for that we need to keep in mind that these new very useful technology called AI ML is in fact responsible as well. With that, what I want to do is to conclude this workshop, and I hope all of you had a wonderful time learning about the basics of AI and ML. So for some, you may have been introduced to some of the ideas that I spoke about in other contexts, maybe in your school, maybe outside, by your own reading, etc., etc. For some, all of this might have been completely new. I know we have a varied set of audience throughout the country, and I'm very happy that we have people from all around the country attending this workshop. So as I said at the beginning, week 1, this is meant to be a very high level introduction, and if you're interested in this topic, I would definitely recommend you to consider a full-fledged degree after after you finish your school, a full-fledged degree in AI and data science. Of course, we have the online BS degree that IIT Madras offers, but then there are so many other degrees as well that you can explore and see. which one fits the best for your purposes. So with that, I will conclude the lecture part of AI/ML workshop. It has been a fascinating experience for me to talk to you, though we have not met live over these lectures, and I sincerely hope that these lectures have, at least ignited a curiosity in all of you to learn more about AI/ML. Thank you very much, and hopefully we will meet some other time. Thank you.